Injecting robots into a human's bloodstream sounds terrifying. But what if I told you science has developed so far that they are actually doing it on purpose? Nanobots in medicine represent a new technology that could save millions of lives. They are the size of antibodies, smaller even than our blood cells, and are the result of spectacular technology and next-level engineering. Nanobots got their name from two words, nano because they're tiny, ranging from 1 to 100 nanometers in size. Just for comparison, human hair is approximately 80,000 to 100,000 nanometers wide. The second word is pretty self-explanatory, robot, because this little creation has an ability to detect cancer cells, specifically targeting them and dropping the cure in order to effectively destroy them. Nanobots are even tinier than blood cells, which allows them to pass into the smallest capillaries and patrol the bloodstream while looking for any sign of distress. This type of medicine allows the nanobots to precisely target cancer cells while leaving healthy cells intact. In the worst case, only a tiny number of healthy cells are killed, mostly those that are surrounding the cancerous ones. This solves the main problem in cancer treatment. The reason why cancer is known to be difficult to cure is because the medicine that the patient takes doesn't have an ability to target cancer cells only, so the medicine ends up killing healthy cells, leaving the patient exhausted and at risk by killing his immunity. Not only will cancer treatments be more efficient, quicker, and less painful, but patients also won't have to go through the side effects of chemotherapy. So, has anyone been cured using this technology yet? No. But the world is getting closer to finally finding a way to cure cancer efficiently. In 2018, a group of researchers injected nanobots into the bloodstream of the test subjects, mice to be more precise. The nanobots traveled through the bloodstream, targeted the blood vessels around cancerous cells, and released blood-clotting drugs. According to the study, the treatment was successful in shrinking the tumors and inhibiting their spread. However, we still don't know when this technology will become the main method to cure cancer. The process of building nanobots is difficult and has to be done slowly and precisely because it's done on microscopic scales. Besides that, the overall process of this treatment isn't only about producing nanobots and injecting them into the bloodstream. Understanding even the tiniest details of this process is very important, including the movements of nanobots inside the bloodstream, their effectiveness, and much more. Thanks to scientists who are maxing out their efforts, nanobots won't only be used in cancer treatments. There are different types of nanobots, such as nanobots for diagnosing a disease, monitoring diabetes, repairing tissue, immune system modulation, and even microsurgery. There's one more very important type of nanobot worth mentioning, respirocytes. Respirocytes were designed back in the 1990s, and their purpose goes beyond our imagination. An artificial red blood cell that can be used to transport oxygen and carbon dioxide in the bloodstream, allowing scientists to produce artificial blood that would be used in blood transfusion and first aid scenarios. Even though a respirocyte is 6 times smaller than a normal red blood cell, it's able to carry 236 times more oxygen and carbon dioxide. This invention would be a huge medical milestone since it would bring a new lifeline for patients suffering from cardiovascular disease. Respirocytes, combined with hemostasis nanobots, will become the best way to take care of a patient that was in an accident and is now losing huge amounts of blood. In these life or death situations, hemostasis nanobots can speed up the process of healing a wound. A 2-micron hemostasis nanobot contains a biodegradable fiber mesh thinner than a single nanometer, which is released into the wound after receiving a command from the control computer. When that fiber mesh reaches plasma water, the fiber mesh dissolves and doesn't let the blood cells exit our body. Even in large wounds, hemostasis nanobots could complete the process in a single second. It feels good to know that technology will solve problems we never could. Each day, nanobots are being researched more and more, and with some luck, they will soon be used to save the lives of millions on a daily basis.